Sometimes bacterial cells cannot carry out cellular respiration due to the lack of oxygen as the electron acceptor, or they lack the genes necessary to carry out respiration. In this case, there must be another way to restore the electron carriers such as NADH to the oxidized state so they can re-enter glycolysis. Fermentation pathways provide a means by which electron carriers can be restored to their oxidized state. Recall that cellular respiration uses oxygen as the final electron acceptor. Fermentation is a metabolic reaction that uses an organic molecule as the final electron acceptor. This process begins with pyruvic acid from glycolysis. Pyruvic acid is converted to ethanol or an organic acid such as lactic acid. Sometimes carbon dioxide is given off in the process. One common fermentation pathway utilized by bacteria is lactic acid fermentation. Pyruvic acid is converted in one step to the 3-carbon lactic acid. Notice that NADH donates 2 protons and 2 electrons to pyruvic acid to make lactic acid. NADH becomes oxidized to NAD. The NAD can now return to glycolysis to pick up more electrons. Different types of bacteria use variations on this pathway to produce many different types of acids, including formic, succinic, propionic, acetic, and butyric acid. In contrast, alcoholic fermentation is a 2-step process. Pyruvic acid first is converted to acetaldehyde, a 2-carbon molecule. The other carbon joins with 2 oxygen atoms to form carbon dioxide, which is given off as a gas. Then, NADH donates 2 protons and 2 electrons to acetaldehyde to form ethanol. After donating its electrons, NADH is now in its oxidized form, NAD. The NAD can now return to glycolysis to pick up more electrons.